Okay, so one is something like A over sine of A equals B over sine of B equals C over sine of C. If you have that completely upside down, I'm fine. If you only did 2 of the letters instead of 3, I'm fine. But something like that is what we're after for 3, or for 1. 2 is C squared equals A squared plus B squared minus 2AB cosine big C. 3, they work for any triangle. 4 is like study of triangles, something like that. 5, we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. 11, use your calculator. 12, do an inverse. 13 to 15.
Isn't it the other way?
No, correct, yeah. 11, do the inverse. 12, use your calculator. Good call. I'm looking at this one and the next one, playing comparison games in my mind, and I lost myself for a second there. The 3 values from the picture, sine is 3/5. Wait, no, lie. Sine is 4/5. Cosine 3/5, tan 4/3. 16 in no particular order is 1.55 and 5.80. 18 is the quadratic formula, which is negative b plus minus root b squared minus 4ac, all on the top, 2a on the bottom. If you have one little mix-up, that makes it wrong. You either have the formula or you don't. There's no like, oh, they forgot the c, that's a half a point. Sorry, it either is or it isn't right on that one. 20, we're hoping for 1.61. I'll do a math explanation if we need it in a second. This is 82.82. Do a math explanation in a minute if needed. This is impossible. It can't be done. I can explain that in a moment as needed. In terms of flashing into the future, well, let's cut the video. We'll do a future flash. Okay, so next time the worksheet will be due tomorrow, and we'll take a slightly reworked version of this quiz. So 1 and 2 and 3 stay the same. And I'll ask you in a minute, what is a problem with the law of sines? So we will get into a conversation over here in a minute about what is a problem with the law of sines. We'll reveal that answer in a moment. The rest of that stays the same, with the exception of when I get to the bottom 3 zone, there's still going to be 3 of them, but it'll use some of the math that we are doing today, but it'll also use some of the math that we have not yet done, that we're about to do in the notes. So it'll be like a mix of a little bit old and a little bit new when we get to the bottom for that. Before we go up to new math, is there anybody from the quiz that just got surprised by the 1.61 that wants help? Did anybody get surprised by 82.82 and needs help? Is there anybody that got surprised by no answer and needs help? Okay, so that's a quick. So into the new world of using law of sines, somebody with experience at this, let's go with a calculus present student. Does that calculus present student, anybody remember a problem with the law of sines? Or I can maybe say a limitation on the law of sines. Yeah, let's phrase that a little different way, but she's in the right zone about something about acute angles. That only matters if we're finding something. Somebody from trades playing along with me there?
If you're trying to find an angle that is possibly obtuse, opposite of the side, then you can't do that.
Okay, that's fine. If we're trying to find angles, you have to know that the angle is acute. If you're using the law of sines to find sides, do whatever you want. But if you're using the law of sines to find angles, you have to have some sort of reasoning process that you know the angle is acute. And that's the quiz question for next time. Something like, what's a problem with law of sines, or what's a limitation on law of sines? I don't remember how I phrase it, but the answer is, if you're finding angles, you have to know that they are acute. Is that going to come up on this picture? No, because what are we finding on this picture? The sides, so we don't have to worry about that. But when I step over into these pictures, that is an issue, because on these pictures I'm finding angles. So we have to be a little more cautious. Here's how you know it's time to use the law of sines versus cosines. If you're going to use the law of cosines, you have to have three sides that all have names. They don't all have to be numbers. One of the sides could be an x. But all three sides need to have some kind of a name on them. Number, number, number. Use law of sines, or law of cosines. Number, number, number. Use law of cosines. Number, number, and there's my x. That's fine. There's three sides. They all have names of some sort. There's a variable we could solve on one of them. That's fine. That's a law of cosine setup if all three sides have names. This is not a law of cosine setup, because even though I did put variables on two of them, can you solve for two variables at the same exact moment? You cannot. So this is not a law of cosines question. Could this one be? Maybe? Yeah, because with a 3, a 12, and an x, yeah, maybe, maybe not. 5, 7, an x? Yeah, maybe, maybe not. 5, 7, x, 5, 4, x, yeah, we could still maybe use law of cosines on some of these. But this one, no. The giveaway for law of sines is when there's an opposite pair where these are both, no. If you have an opposite pair where they're both numbers, it's going to be law of sines time, most likely. I'm going to clear this away. You're only going to need to operate on two fractions at a time. So how do we solve stuff? Algebra skill that looks like those? A lot of cross multiplication in law of sines world. Preference for me personally is to do my variable on the top. So if I go get this x first, who is x's partner in the picture?
70.
70. So I'm going to partner up x and 70. Just like x, who is a side, partners with 70, 6 is a side, partners with 30. I'm missing a crucial thing on purpose. What crucial thing am I missing for the law of sines? The word sine. Okay, where does the word sine always go? With the angles. So 30 was an angle. 70 was an angle. That's how we're going to set up law of sines. Question about setup? Then you could do a full cross multiply, but you don't need to. If you get your x on the top, you just need this to move out. Where would this move out to? The top with the 6. And you can punch in 6 sine 70. When you do sine of 70, the calculator starts you with parentheses, so you have to close them off. 6 sine 70, divide by sine 30. And what we are hoping for, if we're in the right mode and we push the right buttons, we are hoping, yeah, degrees for sure. What I'm hoping for here is an 11.28. People's buttons, do you agree? Yeah. Anybody not liking the 11.28? If I go to get the y, I have a little bit more of a complication when I go to get the y. Y. Bad joke, I know. Bad trick. We need to figure out the angle. But that's not a major life crisis. With which 7th grade type level fact can we figure out what this mystery angle is? The angles have to add up to 180. So far we have 100. This must be the other 80. So triangles, angles add up to 180. That's still a useful fact. So I go y on top of sine 80. Equaling 6 over sine 30. And like last time, this just has to go
5 to 6.
5 to 6. People that are new on these calculators, here's a nice calculator feature for you. hit the yellow button, and then on the bottom, if you already punched this earlier one in, hit the yellow button, and then there's an answer, there's an answer button in yellow, or an entry button, excuse me. We're going second entry. What's entry share a key with somebody with the machine?
Enter.
With enter. So go second and enter, and it basically gives you a calculator instant replay. Okay, we just punched 6 sine 70 divide sine 30, and it just gave you an instant replay of that. Then you could just change the 70 to an 80 and hit the button again, and this time I'm hoping for 11.82. If you didn't understand that instant replay thing, I could try to explain it again. It's a nice feature to save you some button pushing. Question there? Okay, here's a check that we can use, and I'll just rely on you to tell me answers because my calculator is in the lockup zone. You can use law of sines to check all your triangles. So punch with me for a second. 6 dividing sine 30. Just punch that and tell me the first 3 decimals for 6 dividing sine 30.
Wow.
First 3.
That's
It's
it.
just a whole number.
Oh, it just stops.
It's not a
It's
decimal.
just, it's not even a decimal, it's just.
Okay, just plain old 12.
Yeah.
Okay, so 6 dividing sine 30 is plain old 12. 11.28 divides sine 70.
12.0.
Give me the first 3 decimals. 0.004. I have some confidence that I might be right because those are the same, but I won't be truly sure
So you check that.
until I check this one too. So let's go 11.82 divide sine of 80.
12.002.
Since all 3 of these are basically the same, if they all agree, that means everything is right. If one of these disagreed, it means everything might be wrong. Or one thing might be wrong, 2 things might be wrong, we don't know. But something is wrong if they don't all agree. Why didn't they perfectly agree? Because we rounded. We rounded this and we rounded this when we wrote it down, so we're like a little bit off. Okay, but these should all basically agree with each other, and we can check any triangle with that. So if you, someday we'll take a test, a couple days from now, when you turn your test in, you shouldn't have this big mystery like, I hope they're right, I hope they're right. Just go through, if you run that little check, you'll know, like, these are all right, 100%. You'll grade yourself by doing the law of sines little check. You can do every problem that way. Question about that one? So when we cross the line, we have to be a little bit careful. What do we have to be careful about when we cross the line?
You have to know your acute angles, if you're getting angles.
If we're getting these angles, we have to be able to know somehow that they're acute. So we have to reason this out. The basic structure of this is littler sides have to go opposite littler angles. So we try to figure out what's going on. Can anybody spot out of 1, 2, 3, or 4, either something that is acute for sure, is not maybe acute, might be obtuse, or it's just absurdly ridiculous and could not even possibly be a thing? What do you got? 3 is what?
Absurdly ridiculous.
3 is ridiculous, because if 5 is across from 100,
7 has to be.
7, which is bigger, has to be across from something bigger than 100. And already our triangle is over 200. You have to add the 180. There are some questions like this that are impossible, and that's one of them. Can anybody make an observation about something else? Either, hey, that would for sure be acute, or, hey, there's one that's iffy.
1 is acute.
1 is acute. If 12 is opposite 100, 3 would be opposite something less than 100. Additionally, less than 100, something like, can somebody name me less than 100 but still not acute? An example, not in this world, but just in life.
90.
Under 100 but not acute.
90.
90 or
91.
91, a lot of those. Why could this not be a 90-91 kind of thing?
This 3 is not a C is not.
On the right triangle.
180 minus 100, you're only left with 80 to play with between the other two. So this is for sure acute. I'll take a walk over there and I'll get it. So I'm going to do a little cross multiplication, kind of proportion problem setup. I'm going to go x on top because I like my variable on top. X over who?
3.
The 3. Who has sign on it?
X.
The x, because the x was the
And
angle. Okay, the same way that x goes and buddies up with 3,
Well, when I didn't raise it.
sign it
100 goes with 12. And 100 is the
100.
sign. Algebra, who's got to move?
3.
3. So we're going to punch 3 sine 100. Calculator starts you with this, so you'll have to wrap it up. 3 sine 100, wrap it up, divide by 12. Calculator's going to say, oh, I don't know, whatever it says. 0.2 or something. 0.25.
Yep.
Does that seem right that you'd have an angle of 0.25?
No.
No. So quiz answer. How do you find angles?
Inverse.
Inverse. We got rid of the 3 by doing an opposite. We still have to get rid of sine by doing an opposite. So how do we do inverse sine on our machine?
Second sign.
Second sine. So you have 0.25 shown on your screen. Go second sine. And then there's another calculator feature for people that are new on the machines that you can bring your answer back to you. You don't have to re-punch in the 0.25. You can go second sine, yellow button, and then what's the answer key shared with? Is it the negative button?
Yep.
Okay, so we're going second sine, second answer. Answer is written in yellow down on that bottom line. And that's gonna come out in the teens maybe?
14.25.
Something about that. For this one, is this a cube?
Yes. Maybe.
Maybe. Is maybe good enough?
No.
No. You cannot use law of sines the way we just did to get this angle. Because 5's across from 30, 7 is across from something that's more than 30, that's a little bit mysterious. It might be 40 or 50 or 60 and be fine. But it might be 100 or 110 or 120 and not be fine. We can't use law of sines to do this. We would have to use law of cosines, and I'm not going to do that right now. Because the law of cosines would head us down that quadratic path we traveled yesterday. We had an example triangle where yesterday we did a quadratic program and got us the side. Once we had this side, you would know more stuff. Okay? Yesterday, if you had 3 sides on the homework, we were able to get angles. The 82 a minute ago. Okay? We had 3 sides, we got the 82. Okay? Once we had all 3 sides, you'd be able to get this angle. On this one, it is a cube. Because if 5's opposite 50, we catch a break because 4 is
Less than
less than. So this is
less than
less than 50. This would be a law of sines question. I don't feel like doing it right now because we're a little bit cramped on time. It would run exactly like the 14 problem ran. Just like how we got the 14, that's how we could get this one. I think on the homework, it'll probably have you finishing these triangles off. So on this one, once we got the 14, what would be your next move to finish it off? Add up to make this complete the 1/8. Then you could get this with any law that you like. If you like law of cosines better, use it. You like law of sines better, use it. It doesn't matter. Use a law and get that figured out. It's your call now. It doesn't really matter to me. Some of you prefer cosines, most of you prefer sines, maybe whatever. Question about how these went or how we finish them if we had to finish them. This one was finished on its own, so we'll talk about that one. We have like 3 minutes. Let's go. Did anybody have anything on a worksheet that just drove you crazy? And we'll try to remedy that in our 3 minutes. Anybody from 1-6 or from 1-7 have anything? Tomorrow, there's not a lesson. We're at the end of this trig-ish kind of thing. So I actually could give you the practice test now too. I'll do that before you go. Tomorrow, we take a quiz. There's not any new information to teach you. So we have the whole period tomorrow to basically tackle homework issues. But let me give you this. If you want to work ahead, what is today? Today's Thursday, so tomorrow's Friday. We do the quiz that I advertised, and the sheet already in your hands is due. We go on a weekend. We come back on Monday. Monday is not a quiz. Monday would be this sheet, and then Tuesday we would take a test that's like this sheet. So that is our game plan, and we can cut that.